Okay, so we're going to go over Chapter 4. This is a chapter where we take into consideration the effects of the supports of our beam. Now, we're still going to use all the stuff we learned in Chapters 1 through 3. We're going to break our vectors into their horizontal and vertical components. We're going to write our distributed loads as a single vector. And we're going to find the resultant and its location and draw it on our beam. We're going to have to use our algebra skills. We're going to use the three laws of equilibrium. Remember, the sum of the moments about a point is 0. The sum of the forces in the x direction are always 0, and the sum of the forces in the y are also 0. On page 80, if you look, and I think that might be the previous edition, but there's a page in your textbook that shows the different types of supports. Might want to bookmark that. Now, just a note about our negatives. Remember, our negatives can indicate component direction. We use that if it's down or left. We use it to indicate moment direction, either negative. It's negative if it's clockwise in direction and rotation, and it's positive in the counterclockwise direction. The negative can also mean that we made the wrong assumption of direction when we drew our initial sketch of our problem. So here's a problem. Here's the original beam. I have a pin connection at A. I have a roller at B. I have a 3,500 pound force coming down 2 feet from the end of B. I've got a 600 pound per foot rectangular shaped distributed load. I have 8,000 pounds 3 feet from support A. Now, we need to find the reactions at the supports. Remember, we're not taking into account the weight of the beam. We need to find the reaction of our distributed load. So it's going to be 600 pounds per feet times how long it acts over. It's 12 feet. So that's going to be 7,200 pounds. So I drew it right there. Okay. I made the assumption about my supports. I said A of y is pointing up. I said A of x is pointing to the right. And I said B of y is pointing up. Okay. So we start from the same place. Sum of the forces in the x are 0. Well, there aren't any, so A of x has to be 0. We don't know if we assume direction or not correctly because it doesn't matter. Oh, one other thing, that 7,200 pound vector right there, remember that it acts because it's rectangular, it acts right in the center, so it's going to act 6 feet in. Alright, sum of the forces in the y, we're going to add up what we've got. We've got AY pointing up, 8,000 down, 7,200 down, we've got 3,500 down, and we've got BY pointing up. Can't do anything with that just yet. We need to take a moment about a point. Now, we can either do it from A, or we can do it about B, or we could do it anywhere we wanted to. I went ahead and said I'm going to do it from A. So if I do that and I start from A, 8,000 pounds pointing down is going to cause negative rotation. Okay, negative, so it's force times distance plus 7,200 is also going to be negative, and it's 12 feet from point A. 3,500 is also going to cause negative rotation. It's 22 feet from point A. We don't know what B of y is. It's 24 feet away. Set that equal to 0. We're going to solve for B of y. Okay? So we know that B of y points up at 7808. Now, we're going to go back up to our sum of the forces in the y equation and put in what we know B of y to be, and we can find that A is 10,892. Now, in this problem, I made all correct assumptions about A of x, A of y, and B of y, because all my answers were positive. Alright, well, let's look at what happens when we make a wrong assumption. Okay. So I'm going to assume here everything else is the same, except I've said that AY points down, which we know isn't right, but I'm going to go ahead and make the assumption that it does. Sum of the forces in the x is 0. Okay, we're going to write our equations as sum of the forces in the y. Okay, so I've got A of y pointing down. It's negative. 8,000 is negative. 7,200 is negative. 3,500 is negative, and B of y is positive. Can't solve that, so I need to take a moment. Again, I'm going to take my moment about A. That's the same. That's the same. That's the same as last time, b of y times 24. That's also the same. Well, b of y works out to be the same number. That didn't change. But notice when I put b of y back into this equation right here, when I solve that, a of y comes up negative. That negative tells me that a of y is drawn the wrong direction. It should point up, not down.